All right, let's just jump right in. We all know large language models are, well, they're incredible. They can write, they can code, they can summarize things in a flash. But if you're a developer trying to build something real, something reliable, you hit this massive wall. They're just so unpredictable. Trying to get clean, structured data out of them has been this constant, frustrating battle.
And look, this isn't just some small annoyance. As one developer deep in the enterprise AI world put it, this struggle is at the very core of every single AI product out there. It's the one thing that's been holding us back from truly trusting AI agents in production. For the longest time, it honestly felt like a problem that just couldn't be solved. This slide just nails the problem, doesn't it? On the left, you've got this super simple, clear request. All you want is clean data. But on the right, that's what you usually get. It's helpful, sure, but for a piece of software, it's a complete mess. How on earth is your code supposed to parse a phrase like, "I think he mentioned"? It can't. This right here is the chaos developers have been wrestling with forever. But what if we could just skip all that? What if we could force the model to give us exactly what we need in the exact format we need it every single time? Well, a massive shift in how we work with these models is making that a reality. We're talking about a whole new paradigm. The solution is this incredible technology called structured output. And you've got to focus on that key phrase right there, mathematical certainty. This is not about trying to write a better prompt or just hoping the model gets it right this time. No, this is a fundamental change that literally guarantees the LLM's response will perfectly match a specific format you've defined, like a JSON schema. And a really powerful version of this is something called function calling. Now, the name is a bit confusing, I'll admit. The LLM doesn't actually run the function itself. Instead, it acts like a smart dispatcher. Based on what you ask it, it tells your application, hey, you should run this specific function, and then it hands over the perfectly formatted arguments you need to do it. It basically turns the LLM from just a text generator into a system that can take real action.
Okay, so guaranteeing a format with mathematical certainty still sounds a bit like magic, right? How is that even possible without completely breaking the model's creative spark? Well, the answer is buried deep inside the generation process itself.
This slide just lays it out so perfectly. The old way, on the left, I call it the hope and pray method. You'd write these elaborate prompts, then you'd have to build complex parsers and use these brittle regex hacks to clean up the mess, and you'd just be retrying over and over again when it failed. The new way, it's one simple, powerful technique, constrained decoding. So here's the secret sauce. Constrained decoding happens during inference, as the model is generating its answer, one piece at a time. This isn't something that happens after the fact. It's like having a referee watching over the model's shoulder. The model goes to pick its next word or token, and the referee looks at the rulebook, your schema, and literally prevents it from picking a token that would break the rules. Okay, but that brings up a really fascinating problem, right? Because if you're too heavy-handed, if you just force the model down a certain path, you could completely destroy its ability to reason. So the real question is, how do you guide it without, giving it a lobotomy? And this is a real challenge called the token misalignment problem. See, an LLM's vocabulary is made of these things called tokens, and they just don't map cleanly to programming syntax. If you just naively force the model to pick certain tokens, you can send it down a weird path where it struggles. But the really elegant solution researchers came up with is what they call a minimally invasive approach. It doesn't force, it just gently guides the model's choices, just enough to keep it on the right track while letting its powerful brain do all the heavy lifting. All right, that's enough of the deep theory. Let's see what this actually looks like when you sit down to write some code. And the best part is, for you, the developer, it is shockingly simple. It's really just a simple three-step dance. First, you define your rules. Here, it's just a simple Python class. This is your contract with the AI. Second, you feed the model that messy, unstructured text from before. And third, boom, you get back a perfectly structured, validated, and type-safe object. No parsing, no retries, no headaches. Just clean data. Guaranteed. But this is about so much more than just cleaning up data. This is about fundamentally changing how these models interact with every other piece of software. It's about turning the whole world into an API that the model can finally reliably use. And once you have that, everything changes. All of a sudden, you can build agents that reliably pull data from databases, automate really complex workflows, and connect to pretty much any tool you can imagine.
But most importantly, this is what lets us finally build AI software that's testable, that's robust, and that's ready for production.
Of course, anytime you get a powerful new capability like this, it's going to introduce a whole new set of challenges. By giving these models a reliable way to talk to our tools, we also open up new ways for things to go wrong. Security researchers are already all over this. They found a new attack vector they're calling jailbreaking via function calling. The basic idea is a malicious user could craft a very specific prompt that tricks the LLM into generating harmful or forbidden content, but not in its main response. Instead, it hides that content deep inside the arguments of a function call, which can sneak past a lot of the standard safety filters. But as we start to figure out and solve these safety problems, we're left with this really profound question. We're moving away from just talking to AIs and towards a world where they perform complex, multi-step tasks for us. So when an AI can reliably and safely use the exact same tools and APIs that we do, what does that mean for the future of how we build software and maybe how we work all together? And as a final note, this is for entertainment purposes only.